Okay, in this video we're going to take a look at solving a linear system by substitution. It's a very steps-oriented process. I have them listed out 0 to 5. Again, when I, in any of my videos or teaching, list something as step 0, it indicates a step that will not necessarily be required to do in the problem, but you always should look to do it. Some of the problems will necessitate that you do that step. Okay, so let's see, we're going to isolate one of the variables in one of the equations, substitute the isolated variable's equivalent expression into the other equation, solve for the remaining variable, plug that value into one of the original equations, solve for the other variable, write the solution as an ordered pair. Okay, so let's see if in fact we need to do step 0 in this problem. We see that in neither equation do we have a variable by itself. Neither of them say y equals or x equals. So we're going to need to rectify that. So the question becomes, which variable in which equation do we get by itself? Well, let's look for the easiest one. I would think getting this x by itself would be the easiest variable to get by itself. It's going to require one step to do so. That step is to subtract 2y from each side of the equation. Okay? Then when we get that, we get 2y minus 2y cancels. X equals 4 minus 2y. Okay? Because they're not like terms, you can't combine them. Okay, so now substitute the isolated variable's equivalent expression into the other equation. Okay, well let's do some color coding here. The isolated variable is this. Its equivalent expression is this. So what we're going to do is take this expression, 4 minus 2y, and plug it in for x in the other equation. So, let's see, what we're going to get is 3 times the quantity, 4 minus 2y, continuing on, minus 5y equals negative 43. Then we're going to solve for the remaining variable. Well, from here it's the 5-step method that you should have committed to memory. So what we're going to do first is distribute and get 12 minus 6y minus 5y equals negative 43. Then we're going to look to collect like terms, which we can right here. And we're going to get 12 minus 11y equals, excuse me, back to black, negative 43. Okay, then we're going to undo additions and subtractions. So I'm going to take my positive 12 and undo it with a minus 12. And that is going to get me negative 11y equals negative 55. From there, we're going to undo any multiplications and divisions that we have and divide by negative 11 on both sides. This will give us y equals 5. Now, a lot of people would tend to, from here, circle the answer because they've got y equals or some variable equals and think the problem is done. But you notice we have a few more steps to do here. We need to plug that value in one of the original equations. So let's take a look what that looks like. Okay, I'm going to take y equals 5, and I think I'm going to plug it into the top equation because it just looks a little more innocent and less going on. So what I'm going to do is 2 times that y, which is 5, plus x equals 4. Now that I've plugged that in, it should be very intuitive to solve for the other variable. So no distribute, no collect, don't get all your letters on one side. It's really kind of simple. I'm just going to simplify 2 times 5. The only thing we'll need to do is subtract 10 from both sides. Then we're going to get x equals negative 6. Now, we must write the answers in order of pair. So what we're going to get is negative 6, comma, 5. That is the solution to this linear system. That means that these are the two numbers that make both these equations true when you plug them in. In short, it's the point of intersection of the two lines if you graph them. You can check this by graphing, you can check this by plugging plugging the values in for the variables on your calculator and working it out that way to see that both statements are true.